Welcome students. In this video, we will quickly learn the dimensional formulas and SI units of force, work, power, and energy, acting on an object.
Force is a push or pull acting on an object. Its mathematical formula is force equals mass multiplied by acceleration. Mass has dimension m and acceleration t power minus 2. Therefore, the dimensional formula of force is ml t power minus 2. Its SI unit is Newton, represented by N. Now let's learn work. Work is done when a force moves an object through a certain distance. The formula is work equals force multiplied by distance.
Multiplying the dimensions gives ml squared t power minus 2. Therefore, the dimensional formula of work is ml squared t power minus 2. Next is power. Power tells us how fast work is done. The mathematical formula is power equals work divided by time.
Dividing the dimensions of work by time gives ml squared t power minus 3. This is the dimensional formula of power.
The SI unit of power is watt, represented by W. Higher power means more work done in less time.
Finally, let's understand energy. Energy is the capacity to do work and exists in many forms, such as mechanical, electrical, and thermal energy.
Since energy is stored work, it has the same dimensional formula as work. ml squared t power minus 2.
Welcome students! In this video, let's learn the dimensional formulas and SI units of pressure, momentum, moment of force, and impulse.
First, let's understand pressure. Pressure is the force acting per unit area. The mathematical formula is pressure equals force divided by area. Force has dimension ml t power minus 2 and area has dimension L squared. Therefore, the dimensional formula of pressure is ml power minus 1 power minus 2.
The SI unit of pressure is Newton per square meter, also called Pascal. Pressure increases when the same force acts on a smaller area.
Next is momentum. Momentum represents the quantity of motion of an object. Its formula is momentum equals mass multiplied by velocity. Mass has dimension m and velocity dimension lt power minus 1. Therefore, the dimensional formula of momentum is mlt power minus 1.
Now let's learn moment of force, also called torque. It is the turning effect produced by a force. The formula is force multiplied by distance.
Multiplying force and distance gives the dimensional formula ml squared t power minus 2. The SI unit of moment of force is Newton meter.
Next is impulse. Impulse is produced when a force acts for a short interval of time. The formula is impulse equals force multiplied by time.
Force has dimension mlt power minus 2. Multiplying by time gives mlt power minus 1. Therefore, the dimensional formula of impulse is mlt power minus 1. The SI unit of impulse is Newton second, represented as ns. Impulse and momentum have the same dimensional formula. Strain is the ratio of change in dimension to original dimension. Since it is a ratio of similar quantities, its dimensional formula is m0 L0 T0. Strain has no SI unit.
Modulus of elasticity equals stress divided by strain. Since strain is dimensionless, its dimensional formula is ml1T. Its SI unit is Newton per square meter.
Surface energy is energy per unit area. Its dimensional formula is mt meters quarters. The SI unit is joule per square meter. Surface tension equals force divided by length. Its dimensional formula is mt minus tevel. The SI unit is Newton per meter.
Coefficient of viscosity equals force multiplied by distance divided by area. Multidimensional formula is ml1t-1. The SI unit is Newton second per square meter.
Moment of inertia equals mass multiplied by radius squared. Its dimensional formula is ml square. The SI unit is kilogram meter square.